In this video, we will talk about sampling distributions of a difference between two proportions. We will calculate the mean and standard deviation of the sampling distribution of a distance in sampling proportions, p hat 1 minus p hat 2, and interpret the standard deviation. We'll determine if the sampling distribution of the differences between the sample proportions is approximately normal, and if it's appropriate, we'll use normal distributions to calculate probabilities involving the difference between two sample proportions. So here's the basic idea. Suppose we want to know if males or females are more likely to use Twitter. We might take an SRS from each population and compare the sample proportions. Or maybe we are interested in which of two treatments is more successful for helping people to quit smoking. In this case, we could use a randomized comparative experiment to compare the sample proportions from each treatment. In both of these cases, we would end up comparing the difference of the sample proportions in order to make conclusions about the difference in population proportions. Since we are working with two populations or samples rather than one, we need to modify our notation a little bit from what we worked with when we worked with one proportion. So now we've got two separate populations or treatments that we're considering, and we use subscripts to indicate which one we're thinking about when we're writing the parameter p or statistic p hat or the sample size n. So the sampling distribution of the difference between the two p hat, p1 and p hat 2, shows the possible values for the difference in the sample proportions and how often those values occur for all possible samples of size n1 and n2 taken from the two populations that have their own sizes. And note that n1 and n2 do not have to be the same size, nor do the populations that we're studying. Remember that for the sampling distribution of one proportion, we know how to check for normality. We check NP and N times 1 minus P and look to see if they're both greater than or equal to 10. We know how to find the mean of the sampling distribution of those sample proportions. It's just P. And we also know how to find the standard deviation. Of course, make sure you check the 10% condition. Now, that means for each of the two populations we're thinking about, all of those rules apply. We've got the same check for approximate normality, we know how to find the mean of the sampling distribution, and we know how to find the standard deviation. Same thing for population 2. Same formulas, we just use the numbers that are relevant for the second population. Now, the sampling distribution for the difference is how we're combining them. We are subtracting two random variables. So we're going to use the same rules we learned back in chapter 6. If we would like the mean of the sum or difference, it's the same as the sum of the means or the difference of the means. In this case, we're interested in p hat values, and we're interested in the difference. So the mean of the difference is the same thing as the difference of the means. And it boils down to p1 minus p2. That would be the mean of the sampling distribution of the differences of the sample proportions. Now for standard deviations, remember we have the same formula whether we're subtracting or adding. We're always adding the variances and then taking the square root. Well, here we're working with proportions and it's a difference, but we're still going to add the variances for those two proportions. And therefore we have this formula. Now, this formula works as long as the samples are independent from one another and the 10% condition is met for both. And the sampling distribution of the difference between the sample proportions is approximately normal if that large count condition is met for both samples. The standard deviation of the sampling distribution tells us how much the difference in sample proportions will typically vary from the difference in the population proportions if we repeated the random sampling process over and over again. And here's some wording you can use if you're asked to interpret what standard deviation means when you're talking about a sampling distribution of a difference in proportions. So you're going to say the difference, and you're going to say what order you subtracted in. So control minus treatment, or males minus females. That's important because you're establishing which sign, positive or negative, means what. You know, if you got a positive value, does it mean there were more women or more men? So the difference between the two things you're subtracting in the sample proportions of, and whatever it is, P is defined, the proportion of women or proportion of men, typically varies by about whatever the number is that you got from the true difference in proportions of whatever the mean is. So here's an example. Suppose there's a very large high school with a junior class of 800 students, 54% of whom are female, and a senior class with 700 students, 49% of whom are female. The student council selects a random sample of 40 juniors and a separate random sample of 35 seniors. And we're going to let P hat J minus P hat S be the difference in the sample proportions of females, and note that they're subtracting juniors minus seniors. Also note that these two populations are independent. Someone is either a junior or a senior. They're not in both of those groups. So first off, what is the shape of the sampling distribution of P hat for the juniors minus P hat for the seniors, and why? Then we're going to find the mean of the sampling distribution. We're going to calculate and interpret the standard deviation of the sampling distribution, and then we're going to estimate the probability that the proportion of females in the sample from the junior class is less than that for the female class, for the senior class. All right, so here we go for part A, the shape of the sampling distribution. Well, ideally we'd like it to be normal, and the way we check for normality is we check n times p and n times 1 minus p are both greater than or equal to 10, and we do that for both populations, the juniors and the seniors. And in this case, you can see the numbers are all there. All of the values are greater than or equal to 10. Therefore, the sampling distribution of the proportion of juniors minus the proportion of seniors is approximately normal. For part B, they asked you to find the mean of that sampling distribution. Well, remember that the mean of the differences is the same as the difference of the means. The mean for each of the sampling distributions of the sample proportions is the population proportions. So for juniors, that was 0.54, and for seniors, that was 0.49. You subtract them, you get 0.05. All right, let's calculate and interpret the standard deviation. Well, we're going to use that formula. First off, to use the formula, we need to just use the 10% rule and check. 40 is definitely less than 10% of 800, and 35 is definitely less than 10% of 700. So it's okay to use the standard deviation formula. And we're going to plug those numbers in, as you see here. And that gives us a standard deviation of 0.1155. So what that means is the difference, and I subtracted junior minus senior, in the sample proportions of females typically varies by about 0.1155 from the true difference in proportions of 0.05. And finally, part D. We wanted to estimate the probability that the proportion of females in the sample from the junior class is less than the proportion of females from the senior class. Now remember earlier on we said that we have a normal sampling, approximately normal sampling distribution. We computed the mean and standard deviation, which you can see in the notation n parentheses 0.05 comma 0.1155. And we want to know that the probability that the proportion from the junior class is less than the sample from the senior class. So if I did junior minus senior, I should get something less than 0 if it's less. So that's what you see in the bottom line here. The probability that the proportion of juniors minus the proportion of seniors in your samples is less than 0. Use the normal CDF. You can see all the numbers in there, and it's about 0.3325. All right, so now you've got one to try. A researcher reports that 80% of high school graduates, but only 40% of high school dropouts would pass a basic literacy test. Assume that the researcher's claim is true. Suppose we give a basic literacy test to a random sample of 60 high school graduates and an independent random sample of 75 high school dropouts. Let p hat G and p hat D be the sample proportions of graduates and dropouts respectively who pass the test. So the first thing you're going to do is find the shape of the sampling distribution of the difference between the two sample proportions and justify your reasoning. Here's the answer to that part. You have to check that n times p for both groups is greater than or equal to 10. And in all four situations here, you get values that are greater than or equal to 10, and therefore the sampling distribution of the difference between these sample proportions is approximately normal. All right, next, find the mean of the sampling distribution. All right, that's pretty easy because the mean of the differences is the same as the difference of the means. In other words, the proportion for G minus the proportion of D, which is just 0.4. All right, now calculate and interpret the standard deviation of the sampling distribution. Make sure you verify that the 10% condition is met first. All right, well, 60 is definitely less than 10% of all high school graduates, and 75 is definitely less than all high school dropouts, so the condition is met. You can use the standard deviation formula, which you see here. The value comes out to be 0.0766, and that means the difference, subtracting graduate minus dropout in that order, in the sample proportions of those who pass the literacy test typically varies by about 0.0766 from the true difference in proportion of 0.4. And here's the last part. Find the probability that the proportion of graduates who pass the test is at most 0.2 higher than the proportion of dropouts who pass, assuming that the researcher's report is correct. Well, since the sampling distribution is approximately normal, and we know that the mean was 0.4 and the standard deviation was 0.0766, what we'd like to do is find out what the probability is that the difference between those two proportions, subtracted with the proportion for the graduates minus the proportion of the dropouts, is less than or equal to 0.2. We're going to do that with normal CDF. You can see all the numbers in the equation. And that comes out to be 0.0045. Highly unlikely. All right, so that's it for the presentation. You now have some problems to do in your textbook. You can find them on page 500 and 501. You've got number 48 and 52. 52 is going to refer you back to problem 50, which was the U-Try problem that you just did in this presentation. There are also some multiple choice questions for you to do. So, have a good afternoon.